So then let's start recording. That's fine. I'm sharing it and let's do it. All right. I mean, it was announced to be 2 hours. I hope it's going to be much less. So because the conference was big for sure. However, I would say like the key outcomes in summary, I would not say there are too many. Of course, we're going to go through the main trends in general that were presented at this ICML, but for sure it's not that big. Uh, if you want to be socially active and participate in a couple of, let's say, questionnaires, quizzes, you can join. Also, taking into account that we are in Switzerland, if you don't want, you do not join. So basically, nobody forces you. But the QR code is here for you. And yeah, I mean, in general, there are going to be also like the slides with the joining QR code. Well, I see everybody doesn't want. That's fine. That's fine. No problem. I'm gonna answer to the questions by myself. That's okay. Oh, let's wait maybe a couple of seconds for more socially active people to come. Okay. Are you socially active? Not really. That's a pity because I need somebody who's gonna scan a QR code and will participate in my quizzes and questionnaires. I hope it's gonna be you. So I give you a couple of seconds, and meanwhile, I'm gonna say that today it's gonna be just not only ICML conference. We're just gonna touch a couple of trends that I feel they become more and more important. Let's say, and yeah, in general, we'll see what we go through. Okay, good. So you do not want. Then let's go. And you see, there was already the first question immediately going, and I guess that nobody is gonna answer. But if you want, you can, because there is one more chance with QR code. You know, we are in Switzerland. You are also given a second chance. So that's why here you have a QR code. Okay, but basically, I mean, because it is. Narrative, I see. Okay, good. Yeah, there are going to be no tricky questions, I can tell you in advance. So there are going to be only simple questions like this. So you just need to know yourself. Like, you know, in banking, there is know your client, and you just need to know yourself. So AI fields is like exactly language models, generative models, reinforcement learning. This is not a classical allocation of, let's say, what is the field of AI where you work on, because I do not say reinforcement learning, supervised learning, unsupervised learning, but this is just to understand how much what we discussed today gonna be allocated to you. And I think this is pretty good result, because we're gonna exactly talk about these things, not about multimodal AI for sure. Though I would. Okay, that's best that somebody has this multimodal AI, because yeah, as I said, it's not going to be covered, but still multimodal AI is fine stuff, and I would say it becomes quite a trend, and especially we're going to see it also inside the large language models. That's kind of how to join together different types of data works. But for those who don't know ICML, this is just very simple international conference on machine learning. And perhaps those of you who are deep into this topic, you might follow more the NeurIPS, which is more about the neural networks, and ICML. It was originally not only about neural networks, but I would say that recently there is like very slight difference between ICML and NeurIPS. Perhaps at NeurIPS, there are more fundamental openings. So I mean that if you want to wait for, let's say, a big drop and a big news in the world of AI, the next one would most likely come this December at NeurIPS. Yeah. So ICML, this is just a warm up. So you follow the trends, and then you see exactly what these trends lead to at NeurIPS later this year. There are a couple of reviews already done. I would say that they are not as full as our review today. That's why, I mean, you still can visit them, but they're very brief, as it is said here. So ICML, this is, as you can imagine, as long as it is, as I said, kind of the level of NeurIPS, like ton of people. I would say the main headliner at NeurIPS is usually something like OpenAI, recent years, Google research, so like different things like this. And ICML is usually DeepMind is headliner. For some reason, DeepMind tends to submit ton of papers at ICML, and they're always of a good quality. So because I mean, usually Google does not show that much what is going behind the technologies, and that's why people usually need to wait for ICML in order to get what is really going behind the scenes when they are just showing you the touch of their technologies. But yeah, this is how it looks like from the sides. And in the reality, I would say this year ICML, like start obviously in Europe's ChatGPT year, this was 90% about large language models. I mean, this is just the basic stuff, what was shown, like how it progresses. Yeah. So from 2019, it was going. So here it is 2023, but even within this year already, like more advanced models appeared, and we're going to talk in the end about the recent models that were not yet at ICML. But basically, there are too many of them. And I would say, to me, what is more important, why it is going further as a trend, I see that now every company wants to integrate it into its processes. So truly everybody, I mean, you don't know how to use your client data, doesn't matter. So let's try to get some large language model API and do something with it. And maybe we can monetize it. Maybe we can make like a better recommendation system. Maybe we can improve the client's experience, and etc. etc. So I mean, like basically this is about more recently about LLM ops. Yeah, so like how it is going. But today we're not going to touch it. I mean, this is just for you if you're interested in general, what kind of the spheres touched by this LLM in the production, in the real business. But this year, let's say this ICML, it started with such a workshop that was called Physics of Language Models, and it was extremely popular. And I think it was even not a workshop, it was a tutorial, and tutorial normally does not attract that much attention. So tutorials, workshops, they tend to be like the, let's say, even the third one. So the first one usually goes the oral talk, then it goes the poster session, yeah. Then people like attend the workshops and tutorials depending if they have time or they want to have a beer already with somebody who they met at poster session, yeah. So usually it is done like this. So that's why normally workshops and tutorial are put on the first day so that people do not yet know each other and they still do not have friends to have a beer with. So like we have today, yeah, we have beer, so we are already friends. And that's why people now go to workshops and tutorials on the first day. And basically these physics of language models, it was kind of, I would say that if you're interested, you can go through not just ICML link, because after 1 month of the conference, they give all the materials published, but also there is a good website from these guys who are exactly showing what their work was about. And it was about, you know, like very philosophically splitting the concept of intelligence in the LLM into structure, knowledge, reasoning, etc. Which was later this year already proved to be very important. Yeah, we're going to talk about slightly about this OpenAI O1 model. But basically, these guys exactly showed like how this all can be split, how like taking, let's say, synthetic data, you can train LLM that is isolated and trying to, let's say, understand the context. Yeah, they were experimenting with ChatGPT 4 and other models. And I mean, yeah, this is just to say that it all starts usually philosophically. Then, as long as these are like the main trends, later in the year you see how these philosophies they get then into how they materialize. And also the good thing about these particular tutorials and workshop at ICML, I think as long as NIPS, if you go to this website, you're going to have like the video synchronized with slides, also with some subtitles, with comments. And yeah, I would highly recommend it to do this. But starting with philosophy, then it went to the topic that is, let's say, more about the practical things, because, and I would say practical in terms of science, because currently people do not, those especially who use it in industry, yeah, they tend not to fine tune language models. So the best practice that everybody is trying to do is some kind of prompting. We will discuss then what kind of prompting are now on hype. But basically, I would say that yes, pre-training model, then just getting some supervision and then fine-tuning. This was a very old technique that first I think originated in the convolutional neural networks, yeah, when people were extracting some features from the images. So it was pre-trained. You were taking the last embedding layer and then continue fine-tuning your further on model with already features being extracted. And this is basically what the self-supervised, just supervised fine-tuning on LLMs is doing. So basically, some LLM is pre-trained, then you're just getting the last kind of whatever embedding layer extracted, and then you're trying to, let's say, make some classifier or whatever. And usually, in terms of classification, people are, recently interested with all these philosophies of alignment. They are interested in alignment. Yeah, they want to exactly take the LLM and say that, oh no, these kind of answers we would prefer to not to give to users. Yeah, these kind of answers are fine. So basically taking kind of a binary classification task that is performed already on top of pre-trained model, for example. Yeah, and usually in this section, and what is good about ICML, I would say that the level of ideas that are finally developed there, this is not that high top level in terms of mathematics, but still you can get through it. And for example, one of the works was about understanding how fine-tuning on the little known facts can drop your model performance or lead to hallucinations. And then it was said that if it is fine-tuned on random facts and random data, then it can even be better than fine-tuned on little known facts. So, like these kind of ideas, when you are asking yourself like very simple question, like what's going to be if I make the fine tuning on the little known facts, how would it influence? And the main thing is just to then show good experiments and also to make good ablation studies. So if you want to do it, then you can easily go for it. So I mean, later on, I'm going to send you these slides if you want so that you can go through the articles, because here I'm going to leave the links to the articles that I find to be, like, let's say, promising or quite interesting and at the same time easy to understand. And this was kind of one thing. The other thing, it was about the training and like fine tuning of the LLMs, and if LoRa can help to overcome it. Did you use LoRa? Those of you who, because you see, I made it anonymous, so I don't know who said that he works in large language models. Yeah. So, but if somebody of you who works there, maybe you have used LoRa, because LoRa is exactly this technique that is pretty interesting. That is about adding the low-ranking matrices during the fine-tuning, and then training only the specified, let's say, connections in these matrices. So it means that your model does not grow with these additions. And yeah, those of you who are not yet familiar with LoRa, I added a link here. But basically, these experiments, it shows that this stuff works really. So, and basically, it's about, again, getting rid of hallucinations, for example, with this kind of training. And now, I'm talking about fine tuning, yeah. So as I said, that we have a model, then we are making some up training of it. So I don't know if you were the one who is having LLM, and then you have your own needs. What would you do with this? And it's very important. So, like, would you fine tune it? Would you do prompt engineering, or would you RAG? RAG is the retrieval augmented generation, if I'm not mistaken. Okay, so meanwhile, I think a single person here, and this is 100%, he's gonna fine tune everything. So that's good. Yeah. Oh, the problem is that in general that you have, let's say, some new data, some new task that is coming. So, I mean, for example, you're in a company and you would like to, for example, get the user interaction system. So, like, how would you approach it? Because, like, all three things are valid in these terms, yeah. So you can fine tune, you can prompt engineer, you can then make the rack. Yeah. So okay, I see. So there are three people. Oh, that's good. Out of five, three people voted. That's nice. So we have a decision. Uh, hmm, okay. So prompt engineering too. Uh, I would say it's quite important that we understand the difference between prompt engineering. Five people vote. Jesus Christ! What are you doing with me, guys? Maybe somebody is online is also voting because I see that somebody is sitting having no mobile phone in his hands, but that's okay, as I said. But in general, that's interesting. Yeah, the fine tuning. I would say that fine tuning is obviously the stuff that makes sense if you are doing some research things. Yeah, and if you are trying to solve, let's say, the new problem that is somehow even not directly related to the LLM. As I said, for example, alignment. Yeah, alignment can be done only by fine tuning. Then prompt engineering and RAG, I would say that here it is the most interesting stuff that currently I have seen in industry. People are doing RAG so massively, and especially this was about the person who marked multimodal training. This is for you, my friend. So basically, perhaps you are already doing this, but these racks in large language models, they are in fact done with the usage of the vector databases. This is kind of really now cool trend that I like. So when we are talking, for example, about user data, that has different ways. So I mean, for example, in insurance, you might have like, let's say, pictures of the accidents of the previous accidents of clients. You might have the history of communication with the clients. You might have just the tabular data in the database about this client. And basically, when he comes to you and, for example, he wants to, I don't know, get a new offer, or he's just now communicating to your agent, if you're just take the pre-trained LLM model, and if you give to this model not just the prompt that this is the client, blah blah blah, who is trying to get something, yeah. So you can give a simple hint, but if you also take this kind of data that you have, if this data is a priori vectorized, as I said, yeah, so that special vector databases are used behind it, and then these vectors, they are aligned and attached to the, let's say, simple prompt that you are giving just about this client and describing the situation that is going on, yeah, and taking, let's say, his query. Basically, this shows absolutely gorgeous results. So because taking it all together, again, without any fine tuning, this already works pretty well. Yeah, and fine tuning, yeah, this I would exactly. There was very nice question about like what is exactly the task, yeah. So if the task is just like now I have described in industry, this is one case, yeah. But I would say these are the majority in industry cases. If it's like alignments in terms of the data, in terms of like the what to show, what not to show is the output, it is fine tuning. Okay, but now, as long as we are already talking about these things, for example, uh, I would say it appeared not immediately, yeah, with the development of LLM. Only at some point, people came to the fact that it is better to restrict models for their outcome. It is better to say that, oh, no, this is too harsh answer, for example. Yeah, this one we would not get into. Or, for example, if your model can produce several outputs, and for example, you can get some kind of a ranking of the outputs and choose the best one based on some criteria. Yeah, this is also quite an interesting thing that is on the topic of alignment. And it was not immediately clear how to do it because it was like if the person is sitting and then basically trying to like go through all the possible outcomes and say that this is good, this is bad. this doesn't work this way. But it occurs that a very simple approach works, in fact. The approach, I mean, those of you who maybe have seen the movie Social Network about Facebook, if you remember how they were voting for girls, yeah, so, and they were using behind the scenes like the ELO algorithm for the chess players, and basically they were choosing like who is better, the left or the right girl. So it occurred that for LLMs, we can make kind of the same thing. But instead of girls, they're going to be the two outputs of the model for the same query. And just with a little bit of randomization, we are getting two different outputs, and the user decides which one he would choose. And basically iterating through several outputs, and like the case of couples, this is the simplest one. And if you want, you can go deeper and like have several outputs and rank them, and then to assign a reward to them. But I would say this is already a bit more complicated. But if just having prompt chosen response and rejected response, so like this triplet, it occurs that you can very well train your model like your fine-tune classifier, and this would be said like reinforcement learning from human feedback. So because exactly human is making this little markup of the data. So basically he says like, this is valid output, this is, I would say, a less valid output. Maybe it's not even not valid, but it is definitely less valid than this one, yeah? So we are then learning this model. So it takes output one that is rejected, output one that is accepted, and it is basically this model, and it is usually called reward model. Very simple. So we have on top of LLM, we have the reward model that is basically trying to, let's say, push away the final score for these two answers. Yeah. And this kind of idea, I have seen also that you mark like the generative modeling is one of your area of competence. So basically, it was the case one that revolutionized the field of generative adversarial networks, where first it was using just the basic functions like the losses, like the cross entropy loss, MSE loss, etc., and GANs were converging very, very slowly and unstably. But at some point, somebody came up with the Wasserstein laws, if I'm not mistaken. This is how it is called. So it was based on idea of Earth moving distance. It was saying like, why we have like a good and bad, like fake and the true image, just to say that this is fun. Maybe this is very bad and this is very good, yeah? Or there might be just a little bit difference between them. We don't know. But what we can try to do, we can exactly pass this judgment to the model. And when we have like this negative positive, just to try to push it away as much as possible. And this was the idea of such a called Earth moving distance. In fact, it's based on this. I don't remember where it comes from. That it's exactly like the amount of the Earth that you need to move, like from one place to another, in order to, let's say, make it equalize, something like this. But the fact is that here it is kind of the same thing. We do not say that this is 0, this is 1. We're just trying to push them as far away as possible. And originally, idea is very simple. But basically, I would say this year there were many papers that were trying to improve it as much as possible. And there were ideas of combining rewards, and there was like very simple idea. If you look at the formula here, it is just a logarithm, and here it is also like the log sigmoids of the different of rewards. But I mean, it's important to go deeper inside how they are approaching it with the motivation of Kullback-Leibler divergence, and it was occurred to work pretty well. The other one, they were trying to take different reward models and then kind of averaging them. And DeepMind. That was DeepMind. The previous one, I don't remember who was, but this was DeepMind. And basically, this is kind of, these quasi ensemble, but in fact, it's just a voting of independent algorithms. Yeah, that was working pretty well. So there were many of these things. And also, like if we're talking about, let's say, not just trying to when you want to, let's say, write a paper, yeah, and do something in general in a research, yeah, what you are trying to do, you're either trying to improve something or you are trying to get rid of something. So the previous were about improvements. I would say this one is about getting rid of something, because as I said, that this labeling is done by human, yeah, even this coupling, like bad, good response. But these guys, they wanted to see like what happens if we are trying to use the same model in order to just self-instruct for the purpose of then getting this kind of coupling. It occurred to work fine, but I would say that I still stay a little bit suspicious about how they did it. If you want, you can look into this paper, though it's quite interesting and with nice visualizations. So this is, so as you see, there is like everything around LLM to some extent, because first it is just a pure LLM. Then LLM with fine-tuning, LLM with fine-tuning in terms of what? In terms of, for example, making the alignments, and in terms of the reinforcement learning with human feedback. Yeah, so like a separate niche in this task. And the other thing that you can do, like continuing this topic, is if we're talking about this reinforcement learning, I can tell you that I already told you to improve something, to get rid of something, continue getting rid of something. So here, for example, people say, okay, for the majority of these reinforcement learning from human feedback, there was suggested to use this PPO algorithm. So this is proximal policy optimization, I think, or something like this. So basically, when it is based not on the following the target value that we want to, let's say, maximize at the end of the game, but exactly trying to rely on where to move in terms of exactly optimizing the policy itself, but not the reward. They were saying that, come on, this is too complicated for the case of LLM, because LLM is already good enough. It's well pre-trained. We just need to help it a little bit. So then why not to take these PPO off and, for example, use reinforce. So reinforce is exactly the algorithm that is the early version, I think, of these methods of reinforcement learning, and it occurs to work well. So basically, it gave advantage in what? Ooh, less GPU, yeah, and faster convergence. So those of you who now want to go to conference, and I'm pretty sure you all publish, go to conferences, to journals, etc. But I think now the easiest way to go is to say that you have to reduce GPU. So you have to reduce the CO2 footprint. You have to get rid of GPU. You have faster convergence, whatever stuff. So I mean that now people are already not that much care about accuracy. So accuracy 94, 95 doesn't matter. Son, you have the best way of managing GPU. Okay, come in. Yeah, this is your paper is accepted. So think about it. When you're going to be doing your next paper, don't forget to write about your footprint on the planet. But if talking seriously, then still, the paper is good. And yeah, today I'm not showing you bad papers. Bad papers are left somewhere. If, like, again, talking about good papers, yeah, like the majority of today papers, they are from somebody, as I said, like either DeepMind or something, somebody affiliated with it. And for example, this one. This one is about interesting stuff. In fact, this paper, it was not a paper, it was a research from no, it was from OpenAI. This is from OpenAI. So this stuff appeared, I think, last year, but then they wrapped it up into paper only this year at ICML, and it was exactly about this idea of, okay, we are all talking about these LLMs and alignments, but person can judge well up until the moment when the model is, let's say, not outperforming the human. Yeah. So till we are smart enough in order to judge if this response is good or not, or if it is, if let's say it's ethical or unethical, this is fine. But what will happen in the future when the machines become more powerful? Yeah. So you see, the conference is doing kind of the I don't know, parabola, sigmoid stuff, sinusoid stuff. When starting with philosophy, then going into serious articles, then again doing philosophy, but still with very serious articles. And here it was very nice idea, and I would say that I would recommend, in general, to keep this idea in mind when you are doing whatever. Doesn't matter if it is LLM, reinforcement learning, generative methods. When you are taking a little bit weaker model, and that your weaker model that is faster trained, better converged, faster and better converged, and maybe to some suboptimal solution, that you are using this model to mark up in order to uptrain or to fine tune, like in this case, the stronger model. Like here, they were taking the, I mean, it's OpenAI. They have all these solutions. It's all their stuff. So they were taking GPT-2, which is, I think, much less than even GPT-3. So that's why they take GPT-2 and then use this pre-trainment and labeling for then fine-tuning GPT-4. And it occurred to work very well. And I would say this idea, for me, it was working already several times in different ways. When I think in 2018, 19, whatever, so not that much time after Gans appeared, then the next kind of the things was the self-supervision. So people were absolutely crazy about self-supervision. It means that, for example, kind of these autoencoder or whatever. So like I remember there was a boom about the conditional variational autoencoders, whatever stuff. So it means that when you are having the same like kind of inputs, outputs, and then you are trying to extract some additional features just via, let's say, not creating additional labeling. And to me, this is kind of the logical continuation. So you're taking kind of the same architecture. This is just a little bit weaker, and then you're trying to get the bigger architecture better via this weaker one. Also, those who work with generative models, this idea, I think, was very well used in the ProGAN. So there was such an architecture that was called ProGAN. It was progressive GAN, and basically it was generating pictures like one by one, step by step. And I think that I have even seen this idea in diffusion model. Yeah, by the way, I think like this is kind of this stuff is done with stable diffusion as well, where you generate not all the stuff immediately, but you stuff, I mean, ProGAN, it was doing like 2 by 2 pixels, 4 by 4 pixels. Then it was, so next power of 2, and it was like getting more and more details into images, starting with simple methods, and then using what it already has in order to empower the more complicated model. And this more complicated model, it was converging faster and giving much better results, exactly because of already having some output of the previous version of this model that was working on lower resolution. So, gorgeous idea, working, I think, almost 100%. And as you see, paper at ICML is guaranteed. So think for the next year. Then I'm finishing with reinforcement learning and all this stuff because I think it's already too much, but a little bit of reinforcement learning that is not related to LLM. But in general, let's say, what kind of very simple ideas at the first look can bring you very cool results, yeah? Again, DeepMind. And they, for example, I mean, this is, I think, they used, from what I read, they just used the previous ideas from the paper of improving regression performance with distributional losses. And they say, okay, it's clear that sometimes replacing just MSE loss with something more like the classification losses can improve your model stability and convergence. And this is what you will see in many cases. So, I mean, like, basically, I would say that even replacing sometimes MSE with Kullback-Leibler divergence gives you better better outcome. So first of all, because I mean with MSE, the derivative is pretty simple. Yeah. So your optimization happens on just this shrinking of the difference. But for example, what is good about Kubler-Caliber divergence, it could be used, for example, when you have kind of the idea of that you want to get the distance between distributions, yeah? So that you are not just basically shrinking just the loss in terms of simply making these vectors as close as possible, yeah? But you're trying to make kind of distributions as close as possible. And this stuff, they made like, I mean, DeepMind is usually not the deep into theory, perhaps, but deep into experiments. So there were many, many experiments with like how the MSE loss here works, and with let's say classification like, and I tell you that behind the scenes, this is these ideas on the distribution differences. And it occurred to improve like the general reinforcement learning techniques very, very well. I would say also keep in mind this idea for other researchers that just in general, playing around with losses and thinking, if in your particular task you have some, let's say, taste of the distribution behind, so that it is not just simply output, 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 output. Yeah, for example, I don't know, like you have a multi-class classification, whatever stuff. Okay, maybe there is not that much idea of distribution behind. But if you have something that is at least somehow resembles of distribution, then think of using distributional losses, not just basic MSE, because MSE is still going to converge if you have enough data, but most likely it's going to be not as stable as with distributional losses. Okay, shit. I thought that this was the last one about RN. Okay, this one we would quickly skip, maybe, in order not to lose your time. So because as I announced, there are going to be not 2 hours. Now we're going to happily go through the articles and then drink beer and eat shogi. So basically, one more stuff about reinforcement learning. Again, just as an idea for you. That could be, so you see, I'm trying to get the articles that have potential ideas, not only in the area where they are done, but in general outside. So multi-agent reinforcement learning, I would say that I'm even a little bit surprised that it's still a trend. Because I mean, how to say, trend in terms of exactly making these kind of experiments, because multi-agent reinforcement learning is very cool stuff. But I would say, unfortunately, that with the level of complexity of the models that now are there, training the multi-agent reinforcement learning model, even let's say within having, I don't know, resources of Tetave, if you want to do it properly with enough data, this will take quite a time. But there are good news that these methods sometimes get kind of a simplification. And I would say that before, at some point, there was the idea that if you take many, many agents, you would try to train your model, then most likely it's going to work kind of the idea of the wisdom of the crowd or whatever, if we're talking about some collaborative thing, for example. But in this case, for example, people, I don't remember from where they are, maybe also DeepMind. So they suggest the idea of individual contributions as intrinsic exploration. And basically, they look into if some of the agents reach the desirable, let's say, global state under the multiple runs we have, then we can exactly give them like the higher weight, and it like does the mechanism with the Bayesian surprises, and it really cool works with this information transfer. So I would say that the architecture itself might seem to be slightly complicated, but trust me, if you go into paper, it's pretty clear what it's done, what it's doing, and you would see again here KL divergences, sampling, yeah, exploitations, etc., and then just basically this kind of the ICS that works around. Okay, good. Yeah. I don't want you to understand it immediately, yeah, but at least, I mean, just to have the idea for, in general, your research, maybe. I think there was only one person who said that he works in recommender systems. Yeah, and I would say that after all the hype of LLM, finally there were a couple of papers on recommender systems. And as I said, already you have seen like reinforcement learning, LLMs, fine tunings, alignments, etc. And recommender systems, even though there is a trend of applying techniques from LLM to solve the existing problems in the recommender system. And it's quite interesting that when I was younger, one of my PhD colleagues, I think it was the year 2017, something like this. So one of my colleagues, he was doing the recommender system. So he was doing like a very, our group was theoretical computer science, and he was doing very theoretical research on the recommender system. And he was doing it based on, it was sequential based recommender system. And so you can imagine, so 2017, back then it was the hype of applying LSTMs to the recommender system. So to improving like the step-by-step recommendation. And the thing is that now, I guess, like 7 years ago since that time, and the trend that I see, this is again kind of the sequential recommender system, but now this is more like the generative approach, what I see in the recent works, and this is more like the next best action recommendation, kind of this. So I would say in these terms, I see that the majority of the models work like this kind of direction. And but what was on the conference, it was yes, about the generative method, but it was like the majority of works that were there, not only this one, it was about scalability. So it was about how you can make these sequential generative recommendations being scalable when you have like billions of users. Sorry, I mean, not billions of users, yeah, but many, many, many users. You have many, many, many features. And obviously, none of the classical methods, like I'm not talking about collaborative filtering or whatever, would work. Basically, they suggest quite a cool architecture of these like causal mask learned features, and they use I mean, why I'm saying that there are ideas from LLMs, because this is kind of the sequential improvement via the using the cross tangent. So even I mean, like now in this recommender system, these kind of ideas are applied, and this paper was very much discussed. I mean, I've chosen among like a lot of papers that were there. This one was very much on hype because everybody found this architecture very cool, and guys showed, if you go to the paper and to see look at the results, they showed very stable conversions. So they show very good results. Okay, so basically now, after already 46 minutes since the beginning, I think we started a little bit later. I think this was all about XML. So because the conference was absolutely huge, yeah. But yeah, I mean, just to show a little, I mean, they had a little bit better food than we today, so there were more food. But it's interesting, I mean, always to look how the poster session looks like after the conference finishes. So this was exactly ICML of this year, the poster session. And yeah, but after ICML, there were already many things that happened, and I still want to discuss them with you in terms of, because I feel that obviously many of them gonna be the trends of the NeurIPS this year. So, and I mean, for example, one of our colleagues, this guy, he's going to NeurIPS this year, so presenting his work, and I hope you're gonna tell us later on, yeah, what's happening there. But basically, I would say that's obviously robotic stuff is on such a hype. I think since it was NeurIPS 2000, maybe 22. I'm not sure. I think it was already after the ChatGPT was released. And it was the thing that somebody understood that for robotics, obviously reinforcement learning is used heavily for robotics, but somebody understood that pre-training the reinforcement learning for robotics using the diffusion model gives absolutely incredible result. And since people figured it out and presented as NeurIPS, sorry, I don't remember which year, this trend of the new approach of training robots with data and with these ideas of having the pre-training and especially using different architectures of diffusion models, this has become a true trend. And I would say that I expected NeurIPS this year going to be something for sure. The new cool papers, and perhaps some of them would be even groundbreaking on the new data set from Hugging Face. So I think in September or August, so Hugging Face released this Le Robot data set that is in fact like the video synchronized with these analogy data that you see here. And I mean, you can easily take it from here. I think there were even some public challenges and competitions around it. So, I mean, maybe you even participated or not yet. Maybe it's not finished. But in general, I would say that this is definitely kind of a trend. And again, this is not just about the robotics. I would say it was in general the cool thing that pre-training with diffusion models, these are going to be a very cool idea. So basically, like this kind of, like the unsupervised learning to some extent, yeah, or self-supervised learning, whatever you call, and like this self-supervised pre-training with the diffusions. Wow, this was cool stuff. And I mean, like I see in trends that it's becoming more and more and more in power. The other stuff is obviously this OpenAI O1. I think it's going to be presented more in details with more mathematics, perhaps. But I mean, those of you who work in large language model, perhaps you are familiar with this. Those who not yet, there was quite a hype about this OpenAI new method that is, again, saving GPU time and resources on training the model, though then spending this time and resources on inference. So very nice idea of how to sell it, saying that we train less, but now like how much you inference, this is how much we use GPU. So this is your problem. If you use it too much, then you burn GPU. It's not us. So basically, this is kind of the idea that instead of having these chain of thoughts, yeah, so this kind of the prompting engineering idea, yeah, when you have the chain of thoughts that was before, so these very large, very well pre-trained models, and then you are given a prompt, then it responds to you something, you are given additional prompt, then again respond additional prompt, and this is how you are iterating and going through the better solution. OpenAI said that no, now this chain of thoughts, it's gonna be implicitly implemented inside the inferencing, and they even made the advice on prompting. If you want, there is here this guide on the reasoning. Basically, this is kind of the idea of the model that you do not that heavily pre-train, but in reality, what you do, you just then wait with asking a question so that model kind of makes the reasoning and has the internal chain of thought so that you should better avoid chain of thought prompts, because otherwise you're going to confuse the model and basically you're going to make the inference absolutely irrelevant in terms of how much time it's going to take. But this was kind of, let's say, I'm not ready to say yet that this is the next, let's say, best approach in terms of spend time not on training but on inference, because we need to see in details what's going on, yeah? So exactly how this reasoning is organized inside, so because there are still no details about how it is done internally. Though I say that it's a nice trend, yeah? To say that, this is almost as it was once this cool breakthrough with the conditional models. Like, for example, there were just guns, then appeared conditional guns. there were variational autoencoders, and then conditional variational autoencoders appeared. So basically, when you are helping your model somehow, yeah, and this was kind of the idea of this prompt engineering initially, yeah, here as well. And then basically it was now this step of like, okay, let's now put this help into the inference, yeah, instead of the training, but already the inference not from the user, but from the model itself. When it continues improving and improving itself input, yeah, I think kind of what we now already discussed, yeah. So the simpler version initially, yeah, very simple output, very simple answer, then it's getting better and better and better and better via these additional mechanisms that we don't know yet how they work. Yeah, but there are these additional internal mechanisms that are perhaps, I don't know, maybe it works the same like program. Yeah, who knows? Maybe it's just exactly having like internal weak pre-trained models that are then stacking, and then forming these stacked ensemble, and this is how it works. So don't know, no, don't know yet, but I expect that perhaps at NeurIPS this year we're gonna find out how it works. Especially if you go to NeurIPS, talk to guys from OpenAI. They are, let's say, unhappy to talk publicly about the details, but when they are at conference and especially at after party, they are very good at talking about details. So good. Um, and I think as long as we are all in this field, you have already heard. I'm just waiting for the next Nobel Prizes to come this year. Yeah, but I think you maybe as long as me were quite well. Maybe surprised. I was fucking surprised. I can tell you when I had figured out. So first, it was Geoffrey Hinton. Yeah. So I mean, Hopfield. Okay, fine. Hopfield networks. This is exactly physics. But then I have seen Jesus Christ, Geoffrey Hinton. He gets the Nobel Prize and in physics. Yeah, I think Geoffrey Hinton maybe I don't know. I even don't want to know how much physics Geoffrey Hinton knows. Yeah, but basically, like what Geoffrey Hinton did for deep learning, it's absolutely unquestionable thing, because like starting from these exactly Hopfield network, restricting Boltzmann machine, then coming to the architectures. I think people underestimated and didn't understand capsule neural networks. They just didn't understand how to train it well and where to use. Because like pretty fast, the hype of LLM came, and then everybody forgot about it. But I think it was absolutely great in like invention of Geoffrey Hinton. Yeah. So, and then also the guys who have no idea about the proteins, yeah, but they made this AlphaFold. They also got the Nobel Prize, but in chemistry. I don't know. I have seen, let's say, people who say both yes, they deserve it. Yeah, there are people who say no. Where are the true physicists and chemist guys? But I would say that I have a question for you. Like, give a Nobel Prize for AI. So you can respond, you cannot respond. But I mean, like, I'm really interested. Like, what would you say in these terms? I wouldn't say. I would wait maybe at least for one person to say something, and then we will see. I'm not watching who is voting or who is not, so you can do it. I would look at result. So I see. So nobody wants to be on either of the sides, yeah? So nobody wants to be a jerk, yeah? On one hand, we work in AI, and it would be nice to have Nobel Prize, yeah? Ooh, but on the other side, exactly, no. Like, what the fuck to give the physics prize to somebody who has no idea about physics? I absolutely agree. But I mean, in these terms, yeah. But at the same time, I mean, like, it would be nice if, let's say, there was, because there is the Turing Award, yeah, in computer science. But again, it's computer science award. It's not specifically for AI. So, but taking into account how much now people talk about it and how much they use, I guess, yeah, this might deserve it. But perhaps I would agree with this person. Yeah. Uh, we'll see. We'll see how it happens. I have a feeling that next year it's not going to be so. After the scandals, how it was discussed this year, I think this was maybe the first and last year when people like Geoffrey Hinton got the prize in physics. But yeah, we'll see where the world goes. I would say mainly this is all what I wanted to talk about because I think 1 hour is enough in order to go for trends. All the rest of the time we can devote to shogi and beer. But briefly speaking, so we now make this meetup series, and we already had like meetup about the quantum computing and the quantum machine learning, about the difference between different generative methods and how in which situation they are better to be applied. Here I have tried to show you the current trends and to, let's say, give my personal opinion where and how they're gonna be used. But I think that perhaps we can make the same stuff next about the NeurIPS when it comes, or if you know, there is such a cool stuff that is called State of AI. If you didn't read it before, this is the year report that is probably, I don't remember who does it, but it is really cool stuff where it exactly goes through the old trends of the year that is gone. So we can do something like this. We can discuss some recent methods and, for example, then to try them on some real competition in Kaggle, for example, and win money. Yeah, this is another opportunity. Or we can win money at algorithmic challenges, because I mean this is data lab. Yeah, this is about data in general, and I would say algorithms, not only machine learning, is a cool thing. Yeah, so maybe we can participate in some competition. Christmas is coming. There are going to be the advent of code. I don't know if you have participated in it. I find it very cool. I participate every year, first couple of days, then I forget about it. So, but Advent of Code is cool stuff. So perhaps we can do something like this. So I mean, like, I'm really happy if you're gonna give some kind of feedback or whatever. But in general, why join it, Slido again? No. This was about the question answer session. I mean that this is when there are many, many, many people, the same as today. Yes. So people on the other side, they don't see how many. Here, whole room is busy. But they are very shy. So that's why perhaps they are not going to ask the questions, or they're going to ask it like this without the modern technologies. But basically, I would say that was it. So still, thanks for coming. And if you have any questions, please ask them now so that people can hear as well online. Or if you're online, you can also ask questions, maybe in chat, maybe somewhere. Let me see if there is somebody. Oh, there are two people. Okay, nice, nice, nice. So here there are a lot of, and online only two. Okay, that's fine. Okay, but there are no questions in chat. Yeah, thank you, thank you. Good. Then I stop sharing and I stop recording. Okay, good. Then yeah, then that was it. So okay, stop.